All right, we'll pick up where we left off. So we did midpoint formula. Now we're going to do distance formula, and I want to give distance formula, let me just make sure we're rolling here. I want to give distance formula a little bit more time because it is more important, if I'm being honest. It's a little bit more difficult, and we use it a little bit more. So it is important we spend more time on it. So let's just get into distance formula. I have all this here. I don't want to quite get to this yet. You'll see why. Let's just start with Pythagorean theorem, and then we can kind of work up to this. Okay. All right. So we got to know what the Pythagorean theorem is. Okay. I hope you've heard of it. Okay. Pythagorean theorem. I bet some of you guys have it going in your head right now. It's the math formula everybody knows, or at least when they leave high school they do. A squared plus b squared equals c squared. Okay. Bonus points if you know what that means. Okay, you have to put yourself in the shoes of someone from ancient Egypt who had to measure things, maybe like your crops, right angles of your crops. You don't cut into your neighbor's property, okay? Now, in order to do this, they use the Pythagorean theorem, and we have a lot more use for it now today, but they use this to make right angles. And I'll show you how. Okay, let me use the line tool here. All right, so if we have a triangle here, and I want to verify that this is a right angle, there's something that's always true for a right angled triangle, okay? If I have this side's A, this side's B, and this side's C, okay? If I take this value squared, if I take A squared times by itself, and I add it to B squared, it should always equal C squared if this is a right triangle, okay? So let's do an example here. So I'm going to give you something I know to be a right triangle. Okay, and let's just, it's a right triangle, so this should work out, okay? So let's do 3 squared. So 3 squared is 9, plus 4 squared is 16, and 5 squared, oh, lights turned off again, come on lights. And 5 squared is 25. Now we have to verify this. 9 plus 16 is 25. So voila, this is a right triangle. Now, how does this apply to finding the distance? Okay, now, when you guys have a, let me grab a grid here. I had one here, here we go. When you guys have a grid like this, all of these lines are at right angles, right? So if these are at right angles, that means that anytime we draw 2 lines on it, we can use the Pythagorean theorem to find the diagonal. Okay, because this graph is set up so everything is right angles. So what we're going to end up doing is we're going to end up, how far did I go here? We're going to end up being given these 2 lengths right here. We'll square them and add them together, and we're going to find this one here. So really, every time you're using the Pythagorean theorem, you're looking for C. So we want C, that's our distance, okay? Because the diagonal lengths are the difficult ones to find, hence we need a formula to get it. Okay, so in order to find C, if I have this here, if I have, I'm just going to switch the order here, C squared equals A squared plus B squared, well, I can get rid of this squared here by doing the opposite. I don't know if you guys have talked about this last year, but the opposite of squaring something is the square root. So I can square root both sides, and I get C equals the square root of A squared plus B squared. So essentially, we're using the Pythagorean theorem, and we're going to take the square root of whatever we get here to find out what our distance is. Okay, this brings us to the final formula, which is our distance formula. Okay, bear with me, I know it's kind of a lot. So let's say we have a graph here. All right, and just make it kind of a simple graph. And let's say we have point A here and we have point E here. And we want to find the distance between them. We can't just count it because we have a diagonal, right? We can't just count it. So what we're going to do is, in order to find this distance here, we're going to count this here and this here, which makes a right triangle, and we're going to use Pythagorean theorem. Okay, so if you remember back, we did the square root of a squared plus b squared. So now what we're going to do is we're going to replace this with x and y values and do the same formula. So let's say that a, like we said with midpoint, is x1, y1. And let's say that b has the coordinates x2, y2. And once again, we're doing this because this is our first point, which is why they're both 1s. This is our second point, which is why they're both 2s. All right, so we're going to say that our distance, and we'll call that d, or I'll just say distance, equals the square root. And it's going to be a big square because we got kind of a lot going on. And we want to find this length right here. So the easiest way to find this length here is to subtract them. If I take this minus this, I'll get the distance. And we'll do the actual values in a second here. So if I subtract these two, I'll get this distance right here, which we normally would call like a, for our a squared plus b squared equals c squared. So let's subtract them. So we're going to do, in parentheses, x2 minus x1 squared. Because that is our length here. That's our a squared. And then over here, we're going to subtract our y values to get this here. Subtract the y value of b from the y value of a, and then we're going to square that as well. So then we're going to do y2 minus y1 squared. Okay, it's the same thing as Pythagorean theorem. I'll just write it next to it. And by the way, this is the formula. So write that down. Same thing, I'll just write it next to it so you can see the similarity. But because we're on a coordinate plane, we need to actually use the coordinates and subtract them to figure out these distances. Okay? All right, so let's figure out this one right here. And this is the formula we're going to use. All right, so for a, it looks like, based on my picture here, it looks like a is -1, 1. -1, comma 1. And b, based on my picture, is going to be 2, comma 2. All right, so let's plug it into our distance formula. So, and I just abbreviate this as d for distance. So we're going to take the square root of my x2 minus x1. So I'm going to take the x value, my second x value minus my first x value, and I got to be careful because I have a negative here. So I'm going to do 2 minus -1 squared. And then I'm going to do my y2 minus my y1. So this would be 2 minus 1. 2 minus 1 squared. All right, I just want to show you guys something that can save you a lot of time. If you realize this connection, it makes this so much quicker and so much less painful than it needs to be. All right, so I'm going to combine these. 2 minus -1. Remember, if we subtract a negative, it's really like we're adding. So really, this is the square root of 3 squared plus 2 minus 1, 1 squared. Okay, so the reason I point this out is because look at this picture we have here, okay? How far, we're just talking left and right, how far left and right are these away from each other? If we count the spaces, okay? 1, 2, 3, okay? Hence the 3 squared. Okay. How far are these apart up and down? 1. So if you want to avoid this whole x2 minus x1 business, you can just count the spaces left and right, and that's the number you're going to end up squaring, the 3 squared. And if you want to skip counting or subtracting y2 minus y1, you can just count the spaces, and that's the number you're going to square, hence the 1 squared. Okay? All right. All right, let's finish this bad boy up. So we have 3 squared is 9, plus 1 squared is 1. So we have this square root of 10. Sometimes this will work out to be nice. Sometimes it won't. Like if this is the square root of 9, we could just write 3, but it's not. It's a square root of 10. So what I'm going to ask is anytime we get a square root, you take the square root and give me 3 decimal places. Okay? So obviously I don't know this. Let me get a calculator. So I'm going to take the square root of 10. Should be just over 3. So square root of 10. And I get 3.162. And it does keep going, but I'm just going to round to 3 decimal places. Okay? And that will be my answer. Now sometimes the textbook will leave it like this, square root of 10. That's fine. But just know why, where the decimal comes from and why they might leave it like this. Okay? All right, that's distance formula. Like I said, a little bit more difficult, but it really is important because knowing this diagonal comes in handy a lot. Okay, we're going to find the distance of these two. So let's do that. So if you want to pause the video here and try these, go ahead. Otherwise, I'm just going to jump into it. You can follow along. All right, first thing I like to do is label these. This is my x1. This is, oh, sorry, y1. y1. We got x2, y2. Make sure you write these examples down, by the way. If you want to do graph paper, you can. Sometimes that is helpful, so you can do it either way. I'm not going to do it with graph paper. All right, so we have our distance formula. So we're going to do distance equals. It's going to be the square root, and I'm going to subtract x2 minus x1. So 6 minus 3, so it'll be 6 minus 3 squared. And I'm going to do y2 minus y1, so 10 minus 6 squared. And then I can simplify that. All right, so this is just going to be 3 squared plus 4 squared. And I get my distance equals the square root of, what's 9 plus 16? Square root of 25. All right. Square root of 25 is just 5. There we go. So that one ended up really nice. Let's do this one. Okay, so we got some negatives. We got 0. All right, x2 is 3 minus negative 4. Subtracting a negative, be careful. So 3 minus, what did I say? 3 minus negative 4. And we're going to square that. y2 minus y1. So negative 6 minus 0. Squared. All right, 3 minus negative 4. Subtract negative, we add it. We're going to get 7 squared. Negative 6 minus 0, it's going to be negative 6 squared. And we're going to square it the whole thing. Alrighty. So this is 49. Negative times negative is a positive. So it should be 36. So we got 49 plus 36, square root of that. So we have the square root of 85. Okay, now I'm going to get a calculator now, and then we're going to get our answer with 3 decimal places. Because 85 is not a perfect square. We're going to get a decimal. And I think my calculator just died. Nope, there it is. Okay. No, it did die. Come on, calculator. All right, square root 85, 9.2195, so I'm going to have to round that. 9.21, and it's 95, so I'm going to have to round that up, that 9 up to a 10, so that really means it's going to be 9.220. Okay. All right. There we go. That's distance formula. Okay, so you're gonna get some word problems like this. Do one of these, and then I think that'll be it. School is 4 miles east and 1 mile south. You want to picture this, so make sure you draw a picture of your apartment. All right, so we're gonna call your apartment point A, and your school is 4 miles east. Hopefully you know your north, south, east, west. So 4 miles east and 1 mile south of your apartment. This is your school, right? This is your school. Okay. Call that S. Maybe we should get graph paper. We'll see if we need graph paper for this. A recycling center where your class is going on a field trip is 2 miles east and 3 miles north of your apartment. So 2 miles east and then 3 miles north. So this will be 2 miles east and 3 miles north of your apartment. All right, so what is this again? It's a recycling center. We'll call it R. Estimate the distance between the recycling center and your school. Okay, that's not too bad. So it helps to draw a triangle. So let's think about the left and right distance and then the up and down distance. So I'm just going to redraw this here. So for recycling center, let's do it up down first. So up and down distance, it's 3 and then 1. So this will be 4. And then left and right distance, well, looks like this is 2. It's 4 total. So then it's going to be over 2. Recycling center to school, and then we have our diagonal here. Okay. Oh, I guess they did want you to use a coordinate plane. It's fine if you didn't. I should have read ahead. Okay, so now we have this, and now we actually can just use Pythagorean theorems. This is kind of a good example. We don't have to subtract the points or subtract x2 minus x1 because we just have a squared plus b squared equals c squared. Okay? So this is why it's important to understand where the distance formula comes from, because you might be like, oh, what do I subtract? No, it's just, what was I going to say? 2 squared plus 4 squared equals c squared. And you can solve that, and then you're good to go. All right, so we get 4 plus 16 equals c squared, and we get 20 equals c squared. We take the square root of both sides, so we get the square root of 20 equals c. And I need my calculator to get a decimal because that is not a perfect square. That's not going to come out nice. And we get c equals, or our distance, I should say, is 4.472 miles. Are we talking about miles? Yep. Alrighty, that's distance formula. Good luck on your assignment. Let me know if you have any questions, and have a good one.